Okay, let's begin. Hello students, welcome to e-lecture on facts controller, which is very important topic as far as our power system is concerned. So we have lot of facts controller device, but according to our syllabus, we have to cover three important facts devices. That is our first one is STATCOM, that is static synchronous compensator. Second one is TCSC, that is Thyristor control series compensator. And third one is UPFC, that is Unified Power Flow Controller. So in this lecture we are going to cover two fact devices. First one is STATCOM and second one is TCSC. The UPFC we will discuss in the next lecture. Okay, let's begin. In this lecture we will come to know about what is facts, what are the main objective of facts controller, various type of facts controller, benefits of facts controller and its applications. So let's get started. First of all, we discuss about why facts is required. So in a AC transmission system, the ability of transfer power is limited by various of factors like voltage limit, transient stability, short circuit current, thermal stability, etc. Maximum power can be efficiently transmitted through the transmission line without causing any damage to the electrical equipment and the transmission line. So this is normally achieved by changing the power system layout. That is not practically feasible. So to overcome this problem, we introduce variable impedance device like capacitors and inductors. But the whole power from the source is not transferred to the load due to these devices. That means the energy is stored in this device, that is reactive power, returned to the source. Due to this actual amount of power transferred to the load, that is active power, is always less than the apparent power. So to overcome this problem, facts play an important role here. So if we talk about ideal condition, the active power should be equal to the apparent power. So initially we were using mechanically switched devices like series and shunt capacitor or synchronous generator. But the desired output was not that much efficient and response was slow. So to reduce this problem, we use power electronics devices in a transmission system. So if we talk about exact definition of fact device, it is a power electronics based system and other static equipment that provide the control over the one or more AC transmission parameters, right? So these are the objective that is mentioned below. It is increase the power transfer capability of a transmission system to keep power flow over the designated routes. It will secure the loading on the transmission line under the thermal limit. It will maintain the voltage profile over the transmission system, damping the oscillation that may threaten the security of the line capacity. These are the different type of facts compensation. Here we have basic type of fact compensation. In the left side column, we can see that conventional type of compensation devices, which are not much efficient. On the other hand, in the right side column represent the fact devices which are fast and static. Okay, now fact devices further classified into two different groups. The first one, thyristor wall fact devices. The second one is voltage source converter phase devices. So now we will discuss about the series compensation. In series compensation, the facts controller can be connected in series with the line. Okay, it could be a variable impedance such as capacitor, reactor, or a power electronics based variable source of main frequency. Okay,
In case of series compensation, it injects the voltage in series with the line. If the voltage is in phase quadrature with the current controller, supplies or consumes reactive power. Okay. Here we can see the diagram of series compensation, how the fact devices will be connected in a transmission line. There are a few examples of a series controller include triple SC, TCSR, IPFC, TSSC, and TCSC. Okay. So first we have Thyristor controlled series compensation, that is TCSC. TCSC is the series connected device which basically vary the impedance of the transmission line to improve the power transfer capability and improve the voltage profile of the power transmission network. That is why the series compensator is required. We can see that in the figure of TCSC, it consists of capacitor bank is parallel with thyristor controlled reactor. Okay, the triggering angle of the thyristor control the reactor decide whether it act as an inductor for a capacitor, whether it is generate the reactive power or absorb reactive power, and whether the under voltage condition or the over voltage condition. This depend upon the triggering angle alpha. Okay, if we talk about the working principle of TCSC, it can be classified in the two conditions. Okay, the first one, if the triggering angle alpha is 180°, then system work as a capacitor and generate reactive power, right? Whereas alpha is 90°, then it will act as an inductor and absorb the reactive power, right? So the whole mechanism depend upon the triggering angle. Okay, if alpha is equal to 180°, whole system operated by the capacitor. Okay, by the capacitor, by the reactive power and eliminate the under voltage condition. On the other hand, while act as inductor, it absorbs the reactive power and eliminate the over voltage condition, right? Okay, these are the benefits of a TCSC I listed out. So along with that, we can say that it has fast response, simple, and generate less harmonics. Okay, if we talk about the disadvantages, it is a little bit costly and it required protection against fault and it has poor power factor. Okay, after the series compensation, we will discuss about shunt compensation. It could be a variable impedance or a power electronic based variable source or combination of both. It basically injects a current in the system. If the current is in phase quadrature with the voltage controller, supplies or consumes reactive power. Any other phase involve control of both active and reactive power. Now we will discuss about static synchronous compensator, that is STATCOM. It is one of the shunt connected reactive power compensation device that is capable of generating and absorbing reactive power. So the STATCOM is analogous to ideal synchronous machine. So why we are saying that? Because the synchronous machine has no inertia and can internally generate both capacitive and inductive reactive power by changing the field excitation. Here in the circuit shows that it has adjustable voltage source behind the reactance. Next we will see the working principle of STATCOM. The figure shows that synchronous compensator power circuit which consists of one voltage source converter connected to the utility bus through the magnetic coupling here, which will be useful for exchange the reactive power as well as the active power. Okay, so first we will see the exchange of reactive power between converter and the utility bus. There are three cases where we are comparing the magnitude of output voltage of a STATCOM, that is ES, as well as utility bus voltage, that is ET, right? So we will start with the case first. So if we talk about case 1, if the amplitude of output voltage of the STATCOM ES is higher the utility voltage ET, then the current flows from voltage source converter to the AC system, and the converter generate capacitive reactive power to the AC system. Okay, so in second case, if the amplitude of the output voltage of the STATCOM is lesser than the utility bus voltage ET, then the current flow from AC system to converter, and the converter absorb the inductive reactive power from the AC system. Okay, now we will come to the third case. If both the voltage are equal, that is magnitude of ES equal to ET, then there will be no exchange of reactive power. It becomes zero. Then our STATCOM will be in a floating state. This state we call it generally a floating state. So we discuss the case here for the reactive power exchange. Now we see the control of real power exchange by adjusting the phase angle between converter output voltage and the utility bus voltage. We can exchange the real power between the converter and the AC system. It has also two cases. Case first, if the converter can supply real power to the AC system from the DC energy source, if the converter output voltage ES leads with the phase angle of utility bus voltage ET. Okay. In case 2, the converter can absorb real power from the AC system which drives from the DC energy source if the voltage ES lags with respect to utility voltage. Okay, so this is how the working principle of a STATCOM. So now we'll discuss about the location. The best location to install the STATCOM is a midpoint. Why we are saying like that? Because voltage drop along the uncompensated transmission line is largest at the midpoint. Okay, and the second reason is the compensation at the midpoint breaks the transmission line into two equal sections at which the power transmitted as the maximum for the both the section, right? So a STATCOM can improve the performance of the system in the following areas like voltage control, power fluctuations, transient stability, and it can both control not only reactive power but also real power according to system requirement. There are various advantages of fact devices which I mentioned here in brief. You can go through it and then you will become more familiar with the facts controller. Okay, here we can see that the application of facts. We can use the fact devices in the various of aspects such as steady state voltage stability. We can use in the control of power flow. We can damping out the power oscillation. It can be used in HVDC link application and deregulated power system. And last but not the least, it can be used in interconnection of renewable, distributed generation and storage. After so many discussion, we came to know about the fact devices, why it is important in the transmission network. In this video tutorial, we discuss about the working principle of the two main fact devices, that is TCSC and STATCOM. So I will end up this lecture here. We will meet in the next lecture which will be on the our UPFC. Okay, thank you.